Algebra 1 students, here are your 2.10 notes. Change expressed as a percent, and I know you guys understand decimals and you understand that 2.10 is exactly the same as 2.1. However, in our math book, there is a distinction. It's a new section, and we're going to have a good attitude about it, even though apparently our textbook doesn't know how to number things properly. All right, moving on. I'm obviously over it. Tell whether each percent change is an increase or a decrease, then find that percent change. So on number one, we start with an amount of 72. The new amount is 67. To answer the first question, is that an increase or decrease? I just look at the change. That's moving downward, so that is most definitely a decrease. Then it says to find the percent change. So what I'm going to do is to find percent change, we take the difference between the original and new, and then we divide by the original amount. So in this case, we would take 72 minus 67 divided by the original. We always divide by that original amount in this scenario. So that would be 5 divided by 72. When you punch that in your calculator, you get 0.069, somewhere in that vicinity. Now this says to round to the nearest percent, so we would just simply say 7%. All right, let's take a look at the next one. The original amount is 36. The new amount is 68. First thing I notice is that we most definitely have an increase here. If I want to find the percent change, I'm going to take the difference between the new and the original. And really, if we're thinking about this mathematically, it's an absolute value. But what I do is just always take the larger number and subtract the smaller. So 68 minus 36 divided by the original, which is, of course, 36. And that gives us 32 over 36. 32 represents the increase, 36 is the original amount, and we can punch that in the calculator. You get something like 0.888. Now again, this is rounding to the nearest percent, so we'll do 89%. All right, so pause the video, do number 3 on your own, and then compare your answer to mine. You can see my work now. This was obviously a decrease since the original amount was 16. The new amount was 11, and 5/16 amounts to basically 31%. All right, let's find some more ways that percentages are used. This is percent error for estimation, kind of an interesting topic. Estimation is something that we do and all the time in real life, and probably should do even more than we do. We don't trust ourselves enough, and we don't have the number sense to make it work very well for us. So in the example you see here, we see that a building is actually 23 meters tall, but we estimated it to be 20. So the way we find percent error is simply to find, first of all, the raw error, or just the error, as you would probably think of it, which would just come from 23 minus 20, the difference between reality and what we guessed. But then what we do is we divide by the actual amount. So 23 minus 20 divided by 23, and again we're going to round to the nearest percent, and I've got that to be about 0.130. Double checking my division here. Again, I'm just using my calculator to do this. 0.130 looks like a good number to me, which is about 13%. All right, you can look at number 5, and just for the record, I am not yet 38 years old. This is a very old man we're talking about here. So pause the video and calculate the percent error. You can see my work now. I found that the error was 18%. And again, for the record, as of this date, September the 10th, 2014, I am not yet 38. Got a long way to go, almost 2 full months. All right, a measurement is given. Find the minimum and maximum possible measurements. We need to talk about this topic just a little bit before we start trying to answer a question. The concept here is if you're using, say, a tape measure to measure the length of an item, like in this case a baby, but it could be something else. It could be the size of a desk, anything. Essentially what we do is typically we go to a certain unit. Now, in this case, a nurse is measuring a newborn baby. The nurse is saying the baby's 22 inches long. Now, when you read something like that, 22 inches, we know that they've measured to the nearest inch. So what we would do is say, well, how could I get 22? Remember, this is an estimation thing in some degrees because you're looking at a tape measure, a ruler, some other measuring device, and you're going to the nearest value that's on there. So if we're just measuring to the nearest inch, which is what we're doing here, we could be anywhere from 21.5 inches all the way up to 22.5 inches. From 21.5 to 22.5, anywhere in between those two values, the closest inch would be 22. So we say the minimum is 21.5, the max is 22.5. All right, again, pause the video and do number 7 on your own. Welcome back. I found that the range of values for the actual bag of potatoes would be between 3.5 and 4.5 pounds. Again, this is kind of a strange topic. Like, we don't think about this a ton, but it's just a matter of using some estimation skills and considering what happens when you weigh or measure something. Okay, we're going to use those same concepts that we just saw on questions 6 and 7 to look at how that kind of estimation impacts something like area. So let's imagine that you have a rectangle that's 16 feet by 15 feet, and that's what we've measured it as, but we're trying to find the maximum and minimum possible areas. Now, we have to think of this as a couple separate problems. One is, okay, 16 feet. We know 16 feet could be anything from 15.5 to 16.5. That's what we've said is our scale for what our measurements would end up being. Now, 15 feet could go anywhere from 14.5 to 15.5. So essentially what we have here is two different multiplication problems because we're finding area, as it says there, and to find area, you multiply. Now this is the minimum and the maximum. Well, the minimum would come from taking the smallest two values and multiplying them. So we're going to find the minimum area by doing 15.5 times 14.5. And I have that area to be about 224.75 square feet, where the maximum area would be the larger end of the spectrum, 16.5 by 15.5. And that number, if I can read my writing here, I believe that says 255.25. So what we're saying is that when you have a rectangle that's dimensions of 15 feet by 16 feet, and it could be inches or centimeters or any other unit, the area could have a little bit of a range of values. You can see here 224.75 would be the smallest if we've measured accurately, and we could go on up to 255.25. All right, same kind of question on number 9. Why don't you finish these notes up on your own, and then when you come back I'll walk you through what I did. Alright, welcome back folks. For the last time you can see my work on number 9. I found that the area could range from 22.75 square centimeters on up to 33.75 square centimeters. A pretty big difference percentage-wise when you think about it. And we find that with smaller measurements. In any case, I hope this lesson works for you. Come to class to work, and you guys have a spectacular day.